In question 2 of online lesson 3, labor demand, we're going to look at the long run model, where a firm chooses both capital and labor to minimize its cost. You know, because in the long run, we make expectations. We set sales goals, right? We think we're going to be able to sell 1,000 watches an hour. So we got to acquire capital and laborers in certain quantities so we can make that many watches in the future. Okay. In this problem, we're going to let K be the number of coal-fired pizza ovens and L be the hours worked by pizza cooks. Suppose the firm DeFara's pizza production function is given by this equation, Q equals square root of K times L. K is a variable in the long run, and so is labor demand. Both are free in the long run. We can choose K and we can choose L, right? The thing that we're going to hold constant here is output. We're going to hold output constant because maybe DeFara Pizza hired a marketing company, and that marketing company said, hey, you can expect to sell 117.67 thousand pizzas per hour in the future, right? So we're going to take this Q as given, right? And when we solve for K, because we're going to put K on the vertical axis and labor on the horizontal axis, we're going to solve that for K. When you solve it for K, you got to square both sides. Squaring this side results in just K times L. Squaring this side results in Q squared. So you have Q squared equal to K times L. Then all you got to do is divide both sides by L, and you end up with this here, right? And we expect 117.67 thousand pizzas per hour in the future, right? So we're going to place the Q with 117.67. When I square 117.67, I get this number right here, the coefficient of 1 over L, right? Okay. And that's what it looks like right here. Anywhere along this indifference curve, the firm is producing 117.67 pizzas per hour, right? Here, there's a lot of laborers and very little kitchen equipment, kitchens, etc., right? So this amount produces the same amount of pizzas as this point here, right? Here we have a lot of labor and very little kitchen equipment, right? Ovens and whatnot, even kitchens, right? We've stuffed a lot of laborers, a lot of cooks inside of our kitchens. Here we have very few cooks working in our kitchens. Our kitchens are big and we have lots of them, and we have very few cooks in there. So this is very unproductive, and this is very unproductive. But both will produce 117.67 pizzas per hour, right? So that's why we call this an isoquant. Iso meaning the same quantity along the curve, right? Now we're going to use this function here and the cost equation to calculate the stuff in this table, right? So first we need to set the wage equal to $9.60 an hour. We need to set the cost of capital to $17.97 per hour. We have capital equal to something. Initially, capital is equal to 70 in the table. And initially, labor is equal to 131. Both those values are up in the table, right? Now we need the production function. The production function says Q equal to square root. I got to do lowercase letters. Square root of K times L, right? So notice that Desmos automatically substitutes this value into here and this value into here, right? And we get a number 95.76. So my output is 95.76. Now we're going to calculate the cost, right? And the cost is equal to the wage times labor plus the unit price of capital times capital. And the cost of this level of hours of cooks and this level of capital is $2,515.50. Okay. Now, with this amount of labor and this amount of capital, are we able to produce 117.67 units? No, we're falling short, right? Now we expect to sell 117.67, right? So this is what we expect, and this is what we do, right? We undershoot it by 21.91. We undershoot it by 21.91, right? Those are lost sales, right? Those are lost sales. When that's negative, those are lost sales. Okay, now let's do it for ovens. Ovens of, let me switch these. Now we're gonna redo that for 102. We're gonna do that for 102 coal-fired ovens, our capital. And we're gonna hold the number of pizza cooks to 131. Our cost of that capital labor ratio is $3,090.54. Our output is 115.59, with 4 being less than 5. We're going to keep that at 5.9. And then we have lost sales of 208, right? We have lost sales of 2.8. Because again, we expect to sell this much. This is what we expect, and this is what we do. So we're losing sales again, right? Now let's change labor to 161 and choose capital to be 86. This will cost that amount, $3,091.02. Our output will be 117.67. That's a 9, so that'll be 67 there, right? So that's a 9, so that makes that a 7. And we're just hitting our target, right? We're just hitting our target. Now we got a situation where we have 70 units of capital and 191 laborers, right? And this will cost us $3,091.05 or 50 cents, right? Our output is 115.63 because that's an 8. So that 8 makes that a 3. And that, again, we're going to have lost sales of 2.04. Right, lost sales. We need to make that negative. And then we have the final situation where capital is 102. Okay, in this situation, output is 139.58 because that's a 7. That's a 5.8 there. So 7 makes that 8. Our cost is $3,666.54. And we overshoot. We produce too much. And you don't really want to have excess pizza in a given date, because what are you going to do with these pizzas? You're going to freeze them. You're selling freshness, right? You're selling that experience of an authentic Italian restaurant in this town, whatever town you attend these restaurants, right? So you can't just, freeze the excess, right? So it's a waste of money. Now we're going to use the scenarios in the table above to answer the questions. DeFara's pizza costs are lowest in the table when it does what? So we got to look for the lowest pizza cost. And the lowest pizza cost occurs here. And that's when its pizza cooks are 131 and the number of the units of capital is 70, right? I'm going to hit enter and see what happens. Okay, so what's going on here is at this capital labor ratio, at this level of labor and this level of capital, right? We're at this point. And the cost of any point, including this one, on this line is constant at 2,516. Now, this has been rounded right here. We've rounded this to 2,516. So no matter what point you're on this line, it's going to cost us $2,516, or two decimals, $2,515.50, right? And notice this line is not touching the isoquant, right? So there is not one point on this isoquant, isocost. Isocost is analogous to the budget line, right? In consumer theory. There is not one point on this isocost that is sufficient to help us meet our goal of 117.67 units per hour, right? So we're not going to choose any point along this isocost, right? So we're gonna not consider any point along this isocost line, right? All right, and it means we're losing out on sales, right? We're expecting that at this capital labor ratio means we can expect 21.91 thousand lost sales per hour, right? And you can see that graphically because this dot does not touch that curve. If this dot touched that curve, then we'd be making that amount of pizzas per hour, but we're not doing that, are we? All right, DeFara's pizza costs are highest when it acquires what? In the table, the costs of production are highest down here, right? And that's when pizza cooks equals 191. If we demand 191 pizza cooks and demand 102 coal fire pizza ovens, our capital, right? That's going to push our cost to the highest levels of any in this table, right? Also, since we have so many workers and so many coal-fired ovens, we're going to end up producing too many pizzas per hour. We're going to produce 21.91 thousand pizzas more than we need to, right? So that's a big, huge increase in inventory. We want to avoid that, right? Especially when we're talking about gourmet Italian style pizzas, right? We don't want to freeze them and serve them the next day. Okay, so when the firm has a capital level labor ratio of 102 to 191, that means the point that corresponds to that amount of capital and that amount of labor, that point is beyond the isoquant. And every point along this line, along this smooth, flat line, every point there corresponds to a capital labor ratio. And all those capital labor ratios along that line, that negative slope line, all those combinations cost $3,667. So there's a point here and a point here. There's 2 points of intersections, right? The firm doesn't want to choose this point, nor does it want to choose this point. And the reason why that is because the costs are too high. It wants to lower cost, right? It wants just enough capital and just enough labor to produce 117.67 units, right? And that occurs when the firm acquires 86 coal-fired pizza ovens and hires 161 pizza cooks, right? Now, notice what happened here, right? When I entered these two numbers into this particular question, these answer boxes, I get a new ISO cost line, right? My ISO cost line is now just tangent to the isoquant at 0.0, right? I have just enough labor, 161, and just enough capital to make just enough output to meet my sales goal of 117.67 pizzas per hour, right? Okay, so that right there is called the optimal solution, right? That's the optimal solution. The firm minimizes its cost given the output that it wants to produce, right? It wants to produce 117.67 units per hour. Any other combination of capital and labor will either put the firm on this side of the ISO cost, or it'll put the firm on this side of the ISO cost. If you're on this side of the ISO cost, you're not making enough product. If you're on this side of the ISO cost, then your ISO cost line will intersect the indifference curve twice. And that means when that happens, you're not minimizing your cost. So if we end up on this side of the ISO cost line, we are going to have a situation of excess inventory. If we end up on this side of the ISO cost line, then we're going to end up in a situation of lost sales. So the firms want to do just enough so there's no lost sales, and they want to do just enough to eliminate the excessive inventory, right, that they have. Now, moving on. If DeForest Pizza charges $26.67 a pizza, what is his economic profit equal to? Well, the price of pizza, right, is $26.27. The revenue is price times quantity. That's the revenue. And then we got to subtract off the cost, right? And the cost at the profit maximizing level, the cost are what? $3,091.02. So we got to make sure once labor is 161, because we're referring to this optimal point, right? Where costs are minimized, and capital is 86. So when capital is 86 and labor is 161, our cost of production is going to be $3,091.02, right? $3,091.02, right? That's our cost. Our revenue the revenue is what? The revenue is the price here, 26.27, right? Times our quantity. Our quantity is 117.67. I should probably round that. Okay, so if we charge $26.27 a pizza, its economic profit is going to be equal to $3,091 0.19. Yeah, sorry about that. I forgot to, economic profits, the revenue. This right here is basically price times quantity revenue minus the cost. And I had forgotten to subtract out the cost. And then when you do that, the economic profit's $0.17 per hour. Not much, right? And in the long run, we know because of competition, if a market is profitable, if a market is generating above normal economic profits, then that invites competitors, and competitors will enter the market and increase supply and pull down your price, right? Now, after the pizza cooks are form a union, they collectively negotiate a raise in their pay, boosting their hourly wage rate to $17.52 an hour. So the wage rate up here is now $17.52. Okay. As a result of the higher labor cost, Tafara Pizza altered its capital labor ratio to minimize its cost and continue producing 117.67 pizzas. So it acquired 30 new machines, 30 new machines. So optimally, initially we were at 161 and 86, right? 161 and 86. That's where we were optimally before the unionization, right? After the unionization, the wage goes up to $17.52, and it acquired 30 new machines, and laid off 30 pizza cooks. Okay. That resulted in a total of what? 131 pizza cooks and 116 units of capital. 116 units of capital. I had to go back and fix the algorithm because the number here was inaccurate. So subtracting the 30 or adding the 30 new machines, adding the 30 new machines gives us a capital of 116. Subtracting the correct amount of cooks, 42, from the optimal level, right? We got 161 optimally initially, right? 161 initially. So we end up with 119 total, right? And when we hit enter, we get a slide along the difference curve from the original optimal solution to the final optimal solution. F is the final optimal solution. O is the original, right? So we demand fewer of these higher priced chefs. Now that the chefs are higher priced, their labor costs more. We hire fewer of them. It drops 161 down to 119. And then we increase the amount of capital that we acquired. We had acquired 86. We end up acquiring 116, right? So we substitute capital. We substitute labor with capital, right? We're replacing labor, some labor, with additional units of capital. And we go from 0 to F, right? F is our new cost minimizing line. If we're at a point under the ISO cost line, we can't produce enough output, 117.6 units. If we're at a point beyond the ISO cost line, the red ISO cost line, we would not be minimizing cost, right? Our cost would be too high. So our cost minimizing point is the tangent line, the point on the isocost line that is just tangent to the isoquant, right? So F is our new optimal solution. The new capital labor ratio costs a total of what, right? So we have to change the wage rate. The wage rate is now $17.52. The wage was $9.60 per hour, right? The wage was $9.60 hour. Capital is still $17.97, but the hourly wage was $9.60. The hourly wage was negotiated up by the union to $17.52, right? And the new cost of this capital and this labor, where the wage is increased, but the price of capital has not, it's still $17.97. Well, that cost is $4,169.40. Economic profit is what? Well, we're still selling 117.67 pizzas per hour. The price is still, we're going to hold that constant, 26.27 per pizza. So that's our revenue. And our costs are $4,169.40. So our economic profit went from very slightly positive to pretty massively negative. $1,078.21 in a loss. We're making losses now. And that's at a cost minimizing, that's after cost minimized at point F. Now, if it continues to make losses of $1,000 per hour, then it's probably going to eventually do something like maybe adopt robotic pizza chefs, or maybe close some stores in the high cost areas. So this is not sustainable, right?